This is question 1 from exercise 21.5 in Project Maths 2. Below is the graph of the function f of x is x squared minus 2x minus 3 in the domain minus 2 is less than or equal to x is less than or equal to 4. So what they're referring to is this curve we have here on our axis, and we're just going to go through these one at a time. So what we've got to do is we've got to use our graph, first of all, to find the coordinates of the minimum point. So the minimum point on a graph is the point at which the curve stops decreasing and then starts increasing again. So stops going down and starts going back up. So it's going to be right at the very bottom of this particular graph, down there. And the coordinates of that point are 1, minus 4. We can check that out because if we follow our point up to the x-axis we get 1, and if we follow it over to the y we get minus 4. So that's how we got that point. For part 2, we're asked to find the values of x for which f of x is equal to 0. That's another way of saying when y is equal to 0. So we're looking for where the curve crosses the x-axis. And it does so at 2 points, down at x equal to minus 1 down there, and up here where x is 3. So our values of x for which f of x equal to 0 are going to be x equals minus 1 and x equals 3. For part 3, we have 2 parts to this. We're asked to find the values of x for which, firstly, f of x is less than or equal to 0. Now, f of x refers to our curve, and the 0 they're talking about in this case is when y is 0 and f of x is 0, which is the x-axis. So we're looking for the range of values that will make the curve be lower than 0. So we're reading off the x-axis in this case, so it's going to be minus 1 is less than or equal to x is less than or equal to 3, which is just a way of saying all the numbers between minus 1 and 3. And then for part B, we're asked to give the values of x for which f of x is greater than or equal to 0. And that's where the curve itself is above the x-axis. So in our case right now, we're going to have, that's going to happen when x is less than or equal to minus 1. And it's going to happen when x is greater than or equal to 3, like that. Now for part 4, we've got to find the values of x which f of x is equal to minus 3. So there are 2 values of x that when you put them into this curve will give us a value of minus 3 out. So what we're going to do is we're going to go to minus 3 down here. And we're just going to find the points where that cuts the x-axis. So if we work our way across to there, and then we can see if we work our way up from there, which obviously will be done straighter on a page than it is on this, you can see that one of the times is going to be going up to x equal to 0, just up here, because it follows up the y-axis like that. So we're going to have x equals 0, and the other time, reading off the graph, looks like it is close to 2, but not quite at 2, so maybe 1.9, maybe a bit more than that, but we can say it's approximately 1.9. It looks like it's just before 2 as we count our way up on that one. And then for part 5, we've got to find the values of x for which f of x is less than or equal to minus 3. So this is where the curve is beneath minus y equals minus 3, so down this way. So that's going to be 0 is less than or equal to x is less than or equal to 1.9. It's basically just taking our values from before. And the other part of this question is when f of x is greater than or equal to minus 3, so when it's above that. So in this particular case we're going to say that x is less than or equal to 0 and x is greater than or equal to 1.9. Let's draw a line in here so we can fill in some more. We'll go to part 6 just over on the left here. For part 6, we're asked for the values of x for which f of x is first decreasing. So that's where the line, reading from left to right, where the curve goes down. So that happens when x is less than 1. That's the first part, so that's part A for that. And then for part B, we're asked for when it is increasing, and that's going to happen after 1, where the line is going back up again. So in this case, we're going to say x is greater than 1. And that's our part B for this question. And for part 7, we've got to find the values of the f of minus 1.5. So what this is when we got a 1.5 on the x-axis, or minus 1.5 on the x-axis, which is around here on our graph, and we're going to work our way up to our graph from here. It's going straight up away from the x-axis. And when we get to our graph, we're going to work our way from there across to the y-axis. And it looks like we're going to get around 1.9 for that. We're estimating it's definitely beneath 2, and it's between 1 and 2, so we'll call that around maybe 1.8, 1.7, but it's a bit approximate at this point because we're reading it off a graph and we can't be precise without putting the number into the function. So the f of minus 1.5, we're going to say is approximately equal to 1.8. And then for the second part of this, we're asked to get the f of 3.25. So we're going to go to 3.25 on our graph, which is here-ish. We're going to work up to our graph, and then we're going to work across to our x-axis. And this time we get 1. So this one is going to be approximately equal to 1. And the last thing we're asked to do on this is, on the graph, draw the axis of symmetry and state its equation. The axis of symmetry on a graph like this is the line over which, if you folded the graph in half, that the two halves would meet each other neatly. And it's going to go through the minimum point on this graph. So it's going to be the line x equals 1. So it's going to be this line just here, which should have gone neatly through 1, but I drew the best line I could. And the equation of that line it's going to write on the graph is x equals 1. And that is that.